So you have access to the printed solution. I just wanted to run through this verbally for those that might find that helpful. To start with, the question says it needs to stay above 0.015 milligrams per centimeter cubed. So that's why we use the greater than sign. So that explains this greater than sign. And then I'm going to have to move over the 0.15 to make it, to find the critical points. So make it an equal sign and the subtraction. Next step is to find a common denominator, and the common denominator, since this is over 1, is t squared plus 2t, which means I need to multiply this fraction by t squared plus 2t plus 2. So we've got a very complicated numerator, and this in the numerators needs to be multiplied through, which is what's happening in the next step. So I've got 4 terms, and I'm going to collect like terms and make sure that the t squared is written first, the t second, and the constant last. So now to find the critical points, it's where the numerator is 0, and it's a fairly complicated numerator that is not easily factored, which means I'm going to lean on the quadratic formula and plug things into the quadratic formula, and I get 2 times here. Also the second part is where the denominator is 0. So again, I use the quadratic formula for the denominator, where a is 1, b is 2, and c is 2. And what I find is that this is a negative value, so there is no real solution. So I don't have to worry about the denominator being 0. The only 2 critical points are these 2 right here. Now I've put the critical points on the number line, and I test points in each case. Now notice that this here, because we're talking about time, negative time makes no sense. So I start at the number line at time equals 0, and everything less than time equals 0 is irrelevant for this problem. So that means that my number line is actually between 0 and 3.5, and then between 3.35 and 5.64 and beyond. So that is a little bit different than the purely theoretical problems that we have worked on so far. In the applied problems, you have to sort of take out the numbers that makes absolutely no sense. In this case, negative time. Then I've tested all of them, and just like I did in all the other problems before, figured out where the statement is true and realized that the only time that the operation can take place is between 0.35 and 5.64 hours.